Hey everyone, welcome to your video lesson for Unit 3.1. Today we're going to be talking about scatter plots and regression lines. Okay, so scatter plots are used to show bivariate data, which is comparing one quantity to another. Okay, so we could look at two variables such as the age and the weight of the animal, and we could see a trend in the comparison between those two values. Okay, so the reason that we use scatter plots is for a visual display of data to identify correlations, and we use it to make future predictions based on the relationship of those two variables that we see. Okay, so the first thing we want to talk about is the correlation. So the correlation describes the nature and the strength of the relationship between the two variables. Okay, so the nature is referring to the direction that the data is trending. So it could be a positive trend, which looks like a positive slope. We can see that in our first graph. It could be a negative nature, which looks like a negative slope. Or the nature could be no correlation at all, which we see in this third picture, okay, is just data points all over the place, which kind of alludes to the two variables not having a relationship, meaning they don't affect one another. Okay, so that's the nature. The nature is positive, negative, or no correlation. The strength is either strong or weak. So the strength is how close the points are to a straight line. So let's write that down. Okay, so we use the words strong and weak to describe the strength. So you can see in our first graph here, it's a strong positive because you can see that all of those data points are very closely clustered around a trend line. Okay, the second example is a weak negative because you can see that the points are a little bit farther spaced out, but it's still very clear that they're following a negative slope. Okay, no correlation graphs are neither strong or weak. Okay, they don't have a strength. So we want to look at a couple examples here and describe the nature and the strength. So we first want to look, is it a positive or a negative slope? Okay, so these points are very clearly going in a positive direction, okay, because they are increasing, and I would say that this is a strong positive, okay, because they are nearly in a perfect straight line. Okay, looking for a trend here in the second example, I really can't see one. All right, some of the points are maybe falling in a negative line, but then some of them are falling in a positive line. You have some that don't fall anywhere. Okay, so this second example, I would consider no correlation. Okay, and then lastly, this one seems to be going in a negative slope, and since the points are not a perfect straight line, okay, they seem to be a little far off, I'm going to call this a weak negative. Okay, you can have weak positives and you can have strong negatives. Okay. We also want to be able to identify the correlation from a written situation. So maybe we don't have the data points and we don't have the graph, but I still want to know what is happening. Okay. So this situation says the more you practice in comparison to the amount of errors that you make. So it says more practice So practice is increasing. So what would you expect to happen to your errors? You would expect your errors to go down as you practice more. So what kind of correlation happens when one variable is increasing and the other is decreasing? This is a negative. Okay, we cannot identify strong or weak because we do not have a visual representation of the data points. Okay, your test grades in relation to the hours you spent studying. Okay, so let's assume we spend a lot of hours studying. We would hope our test grades go up. Okay, so what kind of correlation do we have when both variables increase? This is a positive. Okay, third, your height in comparison to how well you do in math. Okay, so some of us are very tall, some of us maybe are medium, some of us are shorter, okay, but we're all going to do so well in math that there clearly is no correlation here between those two variables. Okay, so right now I would like you to pause your video and come up with 3 scenarios of your own. So one for a negative correlation, one for a positive, and something for no correlation. Okay, once you have those 3, come on back in and we'll talk about how to construct a scatter plot. Okay, so when putting together a scatter plot, we need a line of best fit, okay, or a prediction equation that best describes how the data is trending so that we can use that to make an approximation of a prediction for future values. Now, it's obviously not going to perfectly model every single data point, but we can get a pretty close answer that I can get something that's pretty accurate for the future. Okay, so the way that we do that is we pick 2 data points from our set, okay, to draw a best fit line through. Okay, remember we need at least 2 points to write the equation of a line so that we can find their slope. Okay, and then using our skills from 3.1, we're going to write a y equals mx plus b form of an equation for our prediction. Okay, so in most cases, we have to create our scatter plot. This one is being given to us, and we're just going to practice writing the prediction equation. So I can see that this best fit line has gone through these 2 points. Okay, so this looks to be about, I would say, 5, 42 perhaps. And this one, I would say 12. 12, 62. Okay, so 542 and 1262. So I'm going to use these as my x1, y1, x2, y2, and I'm going to find the slope of this best fit line. Okay, now for scatter plots, we can divide out our slope and use a decimal. Okay, I would say give 2 decimal places. Okay, if you want to leave it as a fraction, that's fine too. Sometimes it's just easier to work with these numbers when they're decimals. Okay, but this is for scatter plots only. So now using this slope, okay, I can choose either one of those ordered pairs, and I'm going to plug them in. So I'm going to use 542. Okay, and I'm going to solve for my b now. Okay, so now I have a y-intercept as well, and I can write a final answer for this prediction equation, or this best fit line. Okay, and that pretty closely models the data in this set here. Okay, we're now going to make a scatter plot from scratch. Okay, so you're going to need a piece of graph paper, okay, and a ruler. And we're going to start at the very bottom here and build an entire scatter plot, find the best fit line, and then we're going to predict here this very last step. Okay, predict the hourly pay for 15 years of experience. All right, so follow along with me. So you want to have a scatter plot created by the end of this as well. Okay, so remember, in a table of values that is horizontal, the top is my x and the bottom is my y. So the very first thing that I need to think about is a scale. So I'm looking at the x values that I have, and I see they range from 1 to 12. Okay, and I'm going to see, well, how many spaces do I have on my graph? Okay, and I have enough to go by ones, and it's a small enough number that I could go by ones. Okay, if it was a larger range that I had to cover, let's say that it was from maybe 1 to 30, I clearly don't have enough spaces for that, and I really wouldn't feel like going by ones, so maybe I would go by twos in that case. All right, but you have to determine what your scale is going to be. Okay, and now I'm going to look at my y values. Okay, so it's starting at 7 and it's going up to 20. So if I'm not starting at 0 or 1, okay, I'm going to use a break in my graph, and I'm going to start my graph here at 7. Okay, and if I'm going 7 to 20, maybe I want to go by twos. Okay, whatever you choose, you want to make sure that your graph is somewhat spread out on your paper. You don't want it to be super squashed or small in one corner. Okay, and now we can plot our points. Okay, so I have all of my points plotted, and now using a ruler, okay, you're going to try and put in a best fit line. Okay, so I'm looking at my points. I want to make sure that I go through at least 2 and that it represents the data as closely as possible. So I'm going to use 4, 10 and 4, 10, and how about 10, 19. So I'm going to use those 2 points, okay, to go through on my best fit line. And you want to do your best, you don't have to go crazy with it, but you want to do your best to have the same number of points above and below your line. Okay, so I have about 3 below, 9, 17 is really very close to my line, and then I have about 2 above. So that's pretty good enough. Okay, so I'm using the 2 points, 4, 10 and 10, 19, okay, to write my best fit line. So when I do my best fit line, I'm going to first find my slope. Okay, and again, for scatter plots, you can divide this out. That's a nice decimal anyway. Okay, and then I'm going to use one of those points, so I'm probably going to use 4, 10 to solve for b. Okay, so I have my slope and my y-intercept. I can get a final answer here. Okay, so this is for my best fit line. All right, and this wanted me to predict what would be the pay for 15 years of experience. So I want to look back at my table. Okay, experience is the x value. So I have x equals 15 here. So I'm going to take x equals 15 and plug it in to my best fit line. Okay, and I'm going to use that equation to calculate 15 years of experience, what should someone get paid? Okay, and that's telling me it should be about $26.50 an hour. Okay, so that is how we construct a scatter plot from start to finish. We put in our best fit line, solve for the equation like we've been doing for a while now, and then use it to make a prediction. Okay, so please make sure, as always, your notes are complete. You write down any questions that you have, and I will see you next time.